Hello friends, how are you? I hope you are absolutely fine. Today I will discuss about what is the mathematics behind this XGBoost algorithm. So we will not do any delay. So let's start. Okay. So if you have followed my previous video on gradient boosting and what is the supporting mathematics behind this gradient boosting, then it will be pretty easy to understand about the XGBoost algorithm. And the mathematics behind this XGBoost a little bit typical and little bit tricky and little bit tough, but it will be very easy if you follow the whole entire video throughout, and if you before starting the video just go through my whole entire gradient boosting algorithm video. Okay, so after that just it will be pretty easy to understand the XGBoost. The main idea are pretty same, more or less 90% those are similar. A little bit tweaking just will do it in XGBoost. The way over here, then it will converge too fast and it will be much more accurate than gradient boosting. It just will tweak it in such a way. Okay, so just even I will give a hint what I we had done on the gradient boosting algorithm, then you can figure out very easily. Okay, what we had done, that is, first of all, let us take this data set. Okay, so this is your main data set up to this. Okay, this is your main data set. What is it? This is your experience and this is the salary in lakhs. Okay, per annum. So for 5 years experience, the employee gets 20 lakhs per annum. For 10 years experience, the employee gets 30 lakhs per annum. 12 years experience, employee gets 34 lakhs per annum. Okay, so over here, so what was the first idea over here? Try to predict this y0 tax, y0 hat. That is nothing but average of these three salaries. This is a base model. Okay, so from the base model, what will be the residual will be 20 minus 28, that is minus 8. Like this you will get the residuals. Based on this x and the residual, you will have to fit the tree 1. Okay, and you have to predict the residual 1 hat. Okay, so you have to try to predict. Then what will be your y1 hat? That is nothing but these plus this. No, sorry. Just I had done one mistake. That is your. Just I forgot to. Okay, so this plus learning rate into this. Okay, so accordingly you will get your y1 hat. Okay, so after that what you will get over there, that is r2, that is your residual 2, that is this y minus this column. So you will have all these r2s over here, and again what you will do, x and from the r2 you will try to fit t2, and just you will get this r2 hat. Okay, so just you will go on and go on and go on. Okay, up to let's say up to nth step, just you will go on. Okay, fine. Now what is the intuition over here? That is you are growing the trees. You are growing the trees based on the residual and the input vector, and just you are predicting the residuals and you are adding and adding. Okay, so now this is your construct of your tree. So what will, let us suppose you do have another input. Okay, let us suppose say 6 your experience of your experience, and you have to tell that what is the salary. So what you will do, this is your y0 hat. You have to add plus eta, let us suppose eta into what you will do, that is your t1, and you will just give the entry this 6 and this residual. Okay, and then you will get some value over here plus eta t2 like this. You will get all. So you will add on, and then you will, what you will get, you will get the salary over here. So if you take the input as, let's say, take a new input over there, then you will get the output using this model. Okay, you are getting n number of trees and one base model, and just you are predicting for the new features. This is the whole entire idea of the gradient boosting. Nothing different from this idea. Just we will tweak for the XGBoost a little bit more. How to tweak it? Let us suppose just we are adding some sort of parameters to construct the trees, and just we are making change a little bit for the learning rate. Okay. So earlier what we used to do as the learning rate, we used to take one learning rate, let us suppose 0.1, 0.2 like this, between 0 to 1, just used to take one learning rate, and accordingly just we used to try to converge the whole entire algorithm to its actual value. Okay, so just our main intuition behind it was just reduce the loss, reduce the effect of the loss. Okay, so what we used to do, that is nothing but this is your prediction n at the mth step. Over here just you can see first step, this is your what was your prediction over here, that is your prediction at the m-1 step plus eta in, this is your learning rate plus residual. Okay, so you used to do this. Over here what you used to do, instead of taking this residual, this learning rate, you have to use the Hessian. It uses the gradient descent method. It uses the Newton's method. This is your prediction n equals to prediction m-1 step plus residual m divided by Hessian at the mth step. What is the Hessian? So Hessian is nothing but the second derivative. Second derivative is nothing but the Hessian. Okay. So just in some other videos or for upcoming videos also, just how to how the Hessian plays the role for the optimization. If you go through that, then you will surely understand what is the concept and how Hessian used for this particular convergence. Just you can easily understand. Okay. So now we'll talk about this tree construction using these parameters. Just we will use two parameters over here. First one is the lambda, second one is the gamma. Gamma is your threshold value, lambda is your regularization parameter. Suppose we have the residuals in the first step, that is -8 to 6. Okay. Now we are trying to construct the tree. Okay. So suppose just we are bifurcating from the parent node in such a way that your experience is greater than 5 or less than 5. In this branch, if we go towards this node, what we will get, that is less than 5 and this is greater than 5. So if I go for the left side, just we are getting -8 and this is greater than 5, this is your 2,6. Okay. So what is happening over here? One term just that will play the role over here, that is SS, that is your similarity score. What is this similarity score? That is sum of residual square divided by number of residuals plus lambda. For here just you have to sum it up, -8 plus 2 plus 6 whole square divided by 3 plus lambda, that is your 0. And over here just what you are getting, just you can do it of your own, that is minus 8 square divided by 1 plus lambda, this is 64. Suppose let's take the lambda suppose 0, and taking the lambda 0, just we'll try to increase the lambda. Then what will happen, just we'll see it right now. Okay, let's take the lambda 0, and this is similarly for this child 1 node, this is the similarity score, and for child 2 node, what is the similarity score? That is 32. One second. No, sorry, just I had done some, this is 32. How I am telling you? Hi. So this is your 64, and this is your 64 divided by 2 plus lambda. How this 64 is coming? 2 plus 6 square divided by 2 plus lambda. This is 8 square divided by 2 plus lambda. For our first step, just we are initialized in such a way that lambda equals to 0, and so that's why it will be 0, and this will be your 32, correct? This will be your 32. So what will be the gain over here? This is pretty similar to the entropy and those couple of things, information gain, entropy, and those particular concepts. Okay, so this gain is 32 plus 64 minus 0, that is your 96. Okay, and gamma is your threshold. Say your threshold, just you have put, this is your 50. Okay, and taking this lambda 0 and this gamma is 50, so this SS, this gain is greater than 50, then we should go for this particular split. Otherwise we should not go for this split. Okay, so let us suppose you have taken your gamma in such a way that your gamma is 100. Okay, now this gain is less than 100, less than this gamma. Then what will happen? Just will not bifurcate, just will not go for this split. Okay, so what will happen? Just will prune these branches over there. Let us suppose, just I have taken a simple construct over here. If we go for the for the higher constructs, let's say we do have so many branches and all, just how to cut all those branches, just we'll figure it out from this. Okay, so how to cut all these branches. So it means if we increase the lambda, let us suppose if we take the lambda, what will happen? This particular things will go down. Okay, then what will happen? This gain will be less. It means if the gain is is just going down, what is happening? So just we are for just we are entering towards the criteria. Okay, so suppose you have the gain, let's say 60, and your gamma is 60. Sorry, if you suppose your gamma is 70. After adding this, let us suppose some values over here in lambda. Okay, your lambda is going high, so let us suppose you are getting it over here 60. Just then this gain will go down. If your lambda is high, then this gain will go down over here. So then what will happen? So just we are entering in the criteria over there. And another thing lambda does, what is that? Let us suppose there is a extreme effect over here. Suppose there is an extreme effect in this particular over here, because there is minus 8 and 2 6, the data is too much sparse over there, too much sparse. So then if you increase this lambda, so what will happen? Just in the denominator, it will try to nullify the effect of this similarity score, or just it will reduce the similarity score in such a way that it will nullify the extreme effects. So let us suppose over here, just we are going towards the left side, then towards extreme left side we are getting -8, and towards right side 2 6 like this data is too much sparse. Okay, if we increase the lambda over here, then it will reduce the similarity score over there, so it is handling the sparsity over there. Okay, so it handles the sparsity, and it little bit it plays with the the complexity of the trees. Okay, so depth and complexities of the tree effects. Okay, and just we are reducing the complexity of the trees, it means we are reducing the overfitting over there. Okay, so and gamma is strictly used for the controlling the overfitting. Just you had seen over there, just you will use the cutoff, say just you have put the high cutoff over there, so then what will happen, so many branches will cut out over there. Okay, so it means gamma actually strictly if plays the role for the overfitting reduction, and this lambda plays the role in the overfitting reduction a little bit, but it affects the reduce the extreme effects over there. Actually it plays the role for the sparsity reduction over there. So these two parameters are used for the auto pruning for the trees over here. Okay, this is the main idea, this is the main benefit over the gradient boosting. Just in the gradient boosting we didn't use all these parameters for the auto pruning kind of things and handling sparsity kind of things. So these are the parameters we are using over here for the sparsity handling and the overfitting control in XGBoost. So I think this is a little bit clear to you, and just we will go for this particular construct. So this is the way how we fit the tree. So instead of having just over here, just we used to use this tree 1 in gradient boosting. Over here what we will use, tree 1 with a customized tree, that is just we are using this also, lambda and gamma. So this is your XGBoost tree, and this is your gradient boost or ordinary gradient boosting tree, and this is extreme gradient boosting tree. Just we are using the regularization parameter and the threshold also. So that using all these parameters, what we can do, just we can handle the sparsity and the auto pruning. That is the control, overfitting control. Overfitting control will be mainly used just done by this parameter, this gamma, and this by this lambda, just that is the sparsity control, a little bit of overfitting control, but this is the main overfitting controlling parameter over here. So it means just we are using the customized tree instead of this is the ordinary tree. So for the ordinary tree, what you have to use, just you are growing the trees each and everywhere, and for the trees, if it is overfitted, then you have to go check and control, and this couple of things you have to do. But here just if you will choose the set of lambdas and set of gammas, and for the combination of the lambda and gamma where we are getting the least test error. Please subscribe my channel and like this video and press the bell icon for your further notification.